So every real number can be represented as a point on a number line, and the sign of the number indicates its position relative to 0, positive or negative numbers, right? And the magnitude of the number indicates its distance from 0. For instance, on the number line below, each of the numbers, -3 and 3, is located 3 units from 0. So there's my -3, here's my +3. So we can say that each number has an absolute value of 3. And this is the same as writing as absolute value of -3. Remember, absolute value is putting those bars around the number is equal to 3. And that's the same if we did the absolute value of just +3, which is also equal to 3. Because that's the same distance from 0 to each -3 and +3. I'm now going to talk about the different types of numbers. So there's some symbols that we use to identify different types of number sets. You've probably seen these before. So natural numbers, it's indicated by a bold N. Whole numbers is identified by a bold W. Integers, the symbol is a Z. Rational numbers, it's a Q. Irrational numbers is a Q with a line over it. And real numbers, which we're used to seeing, is that capital R, which is bolded. And in addition to these symbols, we use the E, which tells us it's an element of the set. So I've used things like A is an element of all real numbers, which means A is a real number. So when we're looking at the absolute value of a number A would be all real numbers when you do the absolute value of it, because it's the distance from 0 on a number line. 0. Okay, so the first example here, I'm going to determine the absolute value of the following. So the absolute value of 4.2. So from 0 to 4.2, our distance is 4.2. And then from 0 to -6.1, it's 6.1. -3/4 is the same as just 3/4. And then from 0 to 0 is 0. It's also the same as just taking the positive of each of these numbers, right? So the absolute value can be used to determine the distance between 2 points on the number line. So if we're determining the distance between 2 and -5, we're going to put that on a number line. So I'm going to put the point at 2. And -5. You can count the units. 1, 2, 3, 4, 5, 6, 7 units between these two numbers. Or else you can actually subtract the two numbers. So if I did -5 minus +2, so -5 minus 2, it's going to give me -7. And if we take the absolute value of -7, it gives us the number of units between those two numbers. Even if you subtracted the other way, 2 minus the second number, -5, even if you subtract the numbers the other way, you're still going to get 7, and the absolute value of 7 is 7, because this is going to become positive then. And we'll just write that in the blank. So since distance is always positive, it does not matter which point you start with. Just remember to always subtract. And then after you subtract them, take the absolute value. Of the difference. So just like what I did there, it didn't matter I did -5 minus 2 or if I did 2 minus -5. You take the absolute value of your answer and you'll still get the correct number of units between the two numbers. So in this example, we're going to find, using absolute values, determine the distance between each pairs of numbers. So if I'm going between 3.7 and 8.5 and they're both negative, let's just pretend we sketch them. So here's -8.5, and then over here is -3.7. And we want to find how many units. So I could subtract -8.5 minus -3.7. And this would give me -4.8. And I take the absolute value of that, and it's 4.8 units. So if I did -3.7 minus -8.5, that would give me 4.8. And if I did the absolute value of 4.8, that's also 4.8. And then with the next one, we've got 4 2/3 and -5 3/5. I changed these to decimals. So let's just do 4.66666. And then I'll minus -5.6. I'm just going to say that's about 10.3. And then we would take the absolute value, and it would give you 10.3. Number 16. We know that 16 is the same as 4 squared. And it's also the same as -4 squared. So even +4 squared is 16, and then if you did -4 squared, you're also going to get 16. So therefore, 16 has 2 square roots, and we've done this before too in this course. 4 is called a principal square root of 16. And we write this as the square root of 16. And you can represent the positive square root as 16. So on example 3 here, we're looking at a square root of something. So I would work inside my brackets first. We'd do 7 minus 10, which is -3. And this is just coming down to BEDMAS. So you're doing brackets, exponent. So -3 squared is 9. And now if we did the square root of 9, that's going to give me positive or -3. And we can write that simply as the absolute value of 3. And that just comes from the fact now that we know with absolute values that it's either +3 or -3 depending on, the distance from 0, right? So you can just write your answer as the absolute value of 3. I'm going to show you solving these absolute values. So in the absolute value, I would start by doing -26 plus 13, which is -13, minus 2. And then inside the absolute value of 10 minus 16 is -6. And with these absolute values, they're now going to change my answers. So the absolute value of 13 becomes positive 13, and the absolute value of -6 becomes positive 6. And we'll do 13 minus 12, which would give me 1. So I started with this and this, and I changed that to just become positive, and then I just did BEDMAS after that. So the last one is an absolute value again. It's just I have an x value that I'm going to substitute into my equation and then solve for it. So let's substitute x for 2 in. So I'm putting 2 in for x. Just like that. And now I'm going to do everything inside my absolute value first, and then I'm going to do the absolute value at the very end. So I'm going to do negative 2 times 2 squared, which is 4. And then I will do, we can do 3 times 2. Like that. And it's all inside the absolute value still. And then negative 2 times 4 is negative 8. Minus 6 minus 4. That's negative 18 inside. And the absolute value of negative 18 is 18. Numbers 3, 5 to 7, 11 to 12, 14, and if you want, you can give 13 a try.